Good morning, children. Two very good examples from practice set 2.2. Problem number 8, star mark example given on page number 36. And one additional example I have solved for you, which is out of the textbook. Solve this quadratic equation. What is the speciality of this quadratic equation? There is a number containing a root sign, okay, a radical sign. We have to solve this. The method, the fundamentals are exactly same as we did in the previous examples. We wrote given equation is this one. As we normally do, multiply the coefficient of x square with the last number, that is 3 into 2 is equal to 6. Now this product 6 we have to factorize such that sum of the factors must be equal to the middle coefficient. Now 6 can be written as 3 into 2, but the sum will come out to be 5. Not acceptable because the sum required is minus 2 root 6. Now whenever you calculate this product, you have to include the radical sign, the number containing the radical sign in the factors. Now that is the keynote of this problem. Of these types of problems, I am going to give you around minimum 10 problems for homework. The irrational number must be included in the factors. Then you can do it easily. So 6 can be written as root 6 into root 6. But if I take both products positive, then in that case the sum of the factors will be 2 root 6, which is a positive number. We don't need a 2 root 6, we want minus 2 root 6. So both have to be negative. So minus root 6, if you add you get minus 2 root 6, which is the middle coefficient. That means these are acceptable factors of this number. So you have to split the middle number using these two factors. So middle number is written as minus root 6x minus root 6x. If you add, you get minus 2 root 6x. Now from the first two terms, which we normally do, from the first two terms, we have to take a number common. Correct? From these two, we have to take one number common, and from these two, one more number common. What do I observe? This can be written as root 3 into root 3. Suppose I write here like that, root 3 into root 3. Here also root 6 can be written as root 3 into root 2. This square root of 2 can be written as root 2 into root 2. For what reason am I doing this? Because from the first two terms, what can you take common? Root 3 is here, root 3 is here, so we say common. X square is here, that means x is available and x is available here. So from the first two terms, you can take root 3 common as well as x common, therefore root 3x is common. Now if you take root 3 common, this root 3 will remain inside, and from x square, x has been taken common, so x will remain inside. From the second term, this root 3 and this x, they have gone outside, so minus root 2 will remain. Okay. In the same manner, what do we observe here? Root 2 is available here, root 2 is available here. So we will take root 2 common, but as we know that we have to adjust this bracket here, so we will take minus root 2 common, minus root 2. So this minus has gone out, this root 2 has gone out. So what are you left with? Root 3x. Here also 1 plus sign is equal to product of 2 minus sign. So 1 minus sign has gone here, 1 minus sign will be left here. So here you will be left with root 2. So minus root 2, if you take common inside the bracket, again you will get the same terms. So now this complete bracket you can take common. Okay, full bracket is available here and here, so we take it common. So inside the second bracket you are left with root 3x minus root 2. We observe here that the bracket is repeated here. The bracket is repeated. That means bracket multiplied by bracket is equal to 0. So bracket square is 0. So we consider the bracket as one number. So the square of this bracket is 0. Square of a number is 0. Square of a number is 0. So number must be 0. Because 0 square is only 0. Okay. So this number is equal to 0. And if you simplify, minus root 2 will go to the right side. Becomes plus root 2 and root 3 will go in the denominator. So the solution of given quadratic equation is x is equal to root 2 upon root 3 is the root of this equation. This can be written by clubbing the radical sign, root of 2 by 3 also. So whether you write it in that form or in this form, both are acceptable, correct. Okay, so this is one example. Another similar example I am giving you, slightly difficult, okay, and you have to understand this example very clearly, because as I said, I am going to give you 10 examples for homework on the same track. Okay, this is the quadratic equation. We have to solve it. We multiply the coefficient of square term with the last term. I took the product. 6 into minus 7 will be minus 42 into root 2, that is 2. Minus 42 into 2 is equal to minus 84. Okay. The product of these two numbers comes out to be minus 84. So product of first coefficient and the last coefficient is minus 84. Now you have to factorize minus 84 such that the sum of the coefficients is minus 17. Now this is easier as we did in the factorization method. Minus 21 into 4. Okay. If you multiply, you will get minus 84. If you add, the total is minus 17. So this number minus 17y has to be expressed using the factors minus 21 and plus 4. Now whether to write minus 21 in the beginning or plus 4 in the beginning, that you have to decide. So I wrote this as 4y minus 21y. The net result will be minus 17y. So we have written the middle term in the new form. Okay. Now from the first two terms I want to take something common, and even from the last two terms I have to take something common. Okay. So we have to see how can you take something common from these two terms. This 6 and this 4 will give you common factor 2. Understood. This is root 2. But when you take 2 common from here, still 2 will be left. That 2 is written as root 2 into root 2. For what reason? Because you have root 2 available here, and from the second factor you get one more root 2. So 2 root 2 will be common, and also y will be common. Only this is slightly tricky. The factorization of this coefficient. I wrote this as 2 root 2 into root 2. Root 2 into root 2 will be 2. 2 2s are 4. So 4 has been expressed in the new form with the aim that you should get something common from the first two terms. Okay, now let us observe. From this first, that is 6 and 2. From 6 and 2, you can take 2 common. Root 2 is common here. From y square and y, you can take y common. So the net common factor is 2 root 2y. 2 root 2y. From 6 you have taken 2 common, so 3 will be left. This has already gone out. From y square you have taken y common, so y will be left. So inside the bracket you get 3y, and from here you have taken 2 root 2 y common, so only root 2 will be left inside the bracket. I hope it is very clear. 2 root 2 has gone out, y also has gone out, so what is left here? Only root 2. Okay, so the bracket will give you 3y plus root 2. From the last two terms, I am taking minus 7 common, and when I take minus 7 common, again the bracket will have same terms, 3y plus root 2, 3y plus root 2. If you simplify, you will get the same terms. So this complete bracket is common now. The rest of the things are very mechanical. So after taking the bracket common, inside the second bracket you will have 2 root 2y minus 7 equal to 0. So either the first bracket is 0 or the second bracket is 0. Simplify. If you simplify this, you will get this root 2 will go to the right side, minus root 2, and 3 will be in the denominator. Here 7 will go to the right side, becomes plus 7, and 2 root 2 will go in the denominator. Therefore, these two numbers, minus root 2 upon 3 7 upon 2 root 2. These two numbers are the roots of this quadratic equation. So I have explained to you two very important examples. If at all they are asked in the examination with new numbers, you should know the trick of doing it. Okay. So I'll be sending you 10 problems for homework.